Hi guys, my name is Chawit Jittanoon. I'm from civil engineering. My number is 28070503 Today I will be presenting our project, which is surface education. So let's take a look at my teammate.
Chaiwanpen. My number is 58070503213. Civil engineering.
My name is Siraphop Luengvipoo. My number is 58070503220.
Is Pheemmawich cheenlert. My ID is 580705035251.
My name is Aniwat. My ID 5x070503232.
My name is Sittipong. My ID is 58070503258 Civil Engineering.
My name is Paranut. My number is 584070505326 Civil Engineering.
Integral. From this equation, S is surface in space and Phyz is continuous function. To find surface integral, we should show surface on xyz plane. If surface specified by z equal to fxy, surface view on xy plane, we use this equation. If surface specified by y equal to fxz, surface view on xz plane, we use this equation. If surface specified by x equal to y fyz, surface view on yz plane, we use this equation.
Alright, for the orange surface term, there will be two ends value. If n coming out upward from the surface, it will be positive. In contrast, if coming out downward, it will be negative. If you see in the picture right here. And for this for the plane, if for the sphere, n will be negative when n coming inward and positive when n going upward. Right here in the picture, and we can find the value of n vector by this formula right here. N equal gradient f over norm of gradient f.
I talk about surface integrals of vector fields. Look at the picture on this graph. If I have an xyz coordinate axis and surface on this graph, if f is a vector field and s is oriented surface that have n is unit normal vector is outward from the ds, and ds is a vector area that is the same direction with unit normal vector, and ds is of shape is ds equal to unit normal vector ds. Indicate surface that parallel with the coordinate axis. Double integrate surface f dot ds equal to double integrate surface f dot unit normal vector ds. And we call the surface integral that the fact of vector field on the surface.
From the equation, we know that f, the direction of f is go here, and is caused by 6 plane, which is x equals 0, x equals 1, y equals 0, y equals 1, and z equals 0, and z equals 1. Okay, let's start to calculate the first surface. The first surface, the x is equal 0, it means this surface here. And the projection into the yz. Okay, this is equation of this surface. You can see that from the double integrate of f ds we change into the double integrate of f dot n ds. ds when we have to change into more easier, we use the projection of I by z, and we know that x equals 0, so it makes the equation be 0. Okay, the second surface is x equal 1, which is this surface. It's like same as first surface, which is project into yz. Now, but this time it's not x equal 1. It's not x equal 0, but it's equal 1. It's made the equation be like this. Okay, so the result is 2.
At the surface 3, y equal to 0, y equal to 0 is a sign here. N is go in minus j, and the position of the plane zx. This equation look like it, and the answer equal to 0 because y equal to 0. Now go to surface 3. Surface 3 is y equal to 1. Y equal to 1. J in equal to plus j because go here, and the projection of the plane zx in the same surface 3. Equation look like here, and the answer equal to minus 1. And surface 5 is z equal to 0, z equal to 0, n equal to minus k because it go down, and projection of the plane y x. Equation look like here, and the answer equal to 0. At the surface 6 is z equal to 1. Z equal to 1 is here, and n go upward equal to plus k, and projection of the plane in the y-x equation look like here, and the answer equal to 1/2.
Okay, next we will use another method to find flux, such as in this case we use divergence theorem, where equation is double integrate vector f dot vector ds equal triple integrate div vector f dv, which div f equal del dot vector f by f equal 4xi minus y square j and yz k. And next we will calculate and find del dot vector f. We will get curve 4x by curve x plus curve minus y square by curve y, and plus curve yz by curve z dv. And next I will change dv to dz dy dx, and we find boundary. First I find dz. Dz start at 0, final at 1, and we get 0 to 1. And next dv dy start at 0 to 1, we will get 0 to 1. And last dx, the same, dx start at 0 to 1, we will get 0 to 1. And next we will to calculate this equation, we will get 4z minus y, and integrate by dy, dz, I will get 4z square over 2 plus yz finally 021, and we calculate and substituting 1 to z, and we will get 2 minus y, and next we will integrate, we will get 2y minus y square over 2 bodily 0 to 1 dx, and we substituting 1 to y, and we will get 2 minus half dx, and next we integrate, we will get 3x over 2 bodily 0 to 1, and substituting 1 at x, and we will get 3 over 2, where I will get equal the previously. So we will use two methods to find flux. Is 1 surface integral, 2 divergence theorem, but divergence theorem use only chord part, such as in this case is box, is the cube, is chord part, so we will use divergence theorem to find the flux. Okay, finished. Thank you for your attention.